So good morning, one and all. Uh, Let us start today's day two first session, which is fourth session of this particular program. The title of this talk would be Anaerobic Digestion as a System Approach for Biodegradable Waste Management. And today's speaker is Mr. Syed Arifullah, who is the Business Development Manager of Get Green Bioenergy, Bengaluru. So I'll just read out his brief introduction. After his graduation from Bangalore, he started working on waste management, and now he has 4 years of vast experience on waste management, and is working as a business development manager in Get Green Bioenergy, Bengaluru, which is a company which was established in the year 2014, which is MSME ISO 9001 colon 2015 quality management system certified, as well as ISO 14001 colon 2015 environment management. Then it is also certified by Star Suppliers India Mart. The one important thing about this company is they have supplied, they are the manufacturers of this waste management products, and the supply range of this company is throughout India, and some of the composting machines and biogas plants, you can see it in Karnataka, that is SIT Tumkur, and some places in Tamil Nadu also, which were recently planted by Get Green Bioenergy. And coming to the company, Get Green Bioenergy was founded in the year 2014 and headquartered in Bangalore, Silicon Valley of India. So Get Green Bioenergy develop bioenergy projects and technologies that contribute optimally towards a sustainable society. As an integrated technology company, Get Green Bioenergy have expertise in all aspects of environmental efficiency. Their portfolio covers all areas of biogas and biomass gasifiers manufacturing, regardless of the raw materials, the size of the plant, or the process involved. By using their solutions, you will maximize your productivity and minimize your operating costs. Get Green Bioenergy attended over thousands of satisfied customers. So they are into manufacturing of portable biogas plants, which not just fulfill the purpose of managing a family's waste hygienically and safely, but can also address their energy's requirement. Then coming to composting machine, which addresses the waste management needs of residential and commercial spaces. Then they're also into commercial design of biogas plants, because biogas as an energy source on a large scale has considerable advantages in comparison with fast depleting fossil fuels traditionally used for energy production. So the services which they provide to their clients are waste collection, waste water treatment, industrial biogas, portable biogas plants, composting machines, as well as commercial designs for biogas plants. So this was a brief introduction about Mr. Syed, today's resource person, as well as his company where he's working right now. So on behalf of Department of Mechanical Engineering, I thank Mr. Syed Arifullah for accepting our invitation, and today is delivering a talk on anaerobic digestion as a system approach for biodegradable waste management. Thank you, sir. We welcome you. Uh,
Thank you so much, sir. Actually, I should thank you guys, thank you people to give us this opportunity in order to present this in front of the entire the crowd. Thank you so much.
Thank you, sir. It's a pleasure, sir. And the virtual stage is yours, sir. You can
All right.
start your presentation. Thank you.
First of all, I would like to thank MSRIT for giving this opportunity and Pradeep sir and Jyoti ma'am, especially. I also thank on behalf of my company as well, because this is a great platform for us to, train people in how actually the anaerobic digester works in real. All right. With respect to self-introduction, my name is Syed Arif, like Pratik sir told. I've been working with this organization from 4 years into waste management. I've got 4 years hands-off experience on waste management. At the same time, with respect to my company, we are the manufacturers, and we also provide servicing and installation for all the biogas, all type of biogas plants, and we supply product throughout India. Here's some brief presentations about the company that I would like to showcase. Can I, Pradeep sir?
Yeah, sure. You can show it.
So this is my company name, Get Green Bioenergy, and this is how the process works actually. Kitchen waste, from kitchen waste, from the waste, not just kitchen waste, I can say, any biodegradable waste, we can dispose that waste into biogas plant, and then it can be utilized for different purposes, and one of the purposes cooking, and that can be utilized for cooking purpose. So this is the overview of anaerobic and biogas digesters. Basically, it refers to a mixture of different gases, which comes out of the organic wastes and the presence of oxygen as well. And not we can also utilize the municipal waste, agriculture waste, animal waste, flower waste, basic in general, any biodegradable waste, in order to any biodegradable waste can be disposed in the biogas plant, in the anaerobic digester. These are some basic advantages of biogas plant and anaerobic digesters, is that it's eco-friendly, and it produces a lot of it reduces the lot of soil and water pollution, I'm sorry. Biogas also produces the fertilizers. That's the natural, that's the best fertilizer, I must say. That's basically, it's called as manure. All right, it is simple and cost effective, and it also gives a gas which is like healthy and healthy for cooking. So these are some basic compensations that we get from biogas plant and anaerobic digesters. That's the percent components of methane percentage is like, it certainly depend on the amount of waste and the quality of waste that we dispose. Based on that, we get the percentage of methane from 750 to 75%, and the other compensations are carbon dioxide, nitrogen, hydrogen sulfide, and oxygen. These are some basic, like, these are the components, these are the mixture of gases that we get from anaerobic digesters basically. And it all depends on the amount of waste that you dispose, and the quality of waste, also how it is mixed with the ratio of water, considering, and also the soil energy, heat energy, temperature. All these factors are considered in order to produce these gases. So this is something about the company and the background of anaerobic digesters. I would like to share more about the digesters now. Does anyone have any questions so far?
Sir, when you do this process, can you hear me?
Yes.
Yeah. So it tells that it produces around 26 to 50% of carbon dioxide.
Yes.
So the gas, what you use it for cooking, it contains methane. That is fine.
Correct.
So what do you do with this carbon dioxide?
It is when we use the gas for cooking purpose, it is the mixture of all the gases. We're not
Okay.
purifying it here. When we purify it, that's when you get 100% methane.
Okay. Okay.
So when we cook, it is a mixture of all the gases. Yes, considering the fact of water content in the gas, we add a moisture traps to the plant in the pipeline specifically, where the water content will be reduced, but all the other gases will be there. When the percentage of methane is 50 to 65 or 50 to 75, we can easily flame it.
Okay.
Without any purification.
So carbon dioxide, you are going to emit to the atmosphere. Is that correct?
Correct, sir.
Okay. Okay, sir. Thank you.
Any other questions?
Hello, I have a question here, sir.
Yes,
Can you able to hear me?
Yes.
Yeah. Can this be installed at the domestic home level, sir? I mean, house level?
Yes, ma'am. It is.
And what will be the maintenance and the per day basis, how much I'm able to work out with that?
First, I'll show you the picture of the domestic plant that we can actually install in the house for a family of the capacity. There are different capacities for.
Let's say example family of 6.
Sure. I'll show you a video. I mean, like a picture and a video, which actually helps us understand more as to know how we can install this house for household purpose, and also the space required for us for a family.
Yeah, sure.
One second, just a minute.
Yes, sir.
So can you see a picture of biogas plant here?
Yeah, yes, sir.
All right, this is the smallest capacity of the plant. This is the smallest capacity of biogas plant.
Okay, what is the capacity, sir?
This is the capacity of this plant is 1 cubic meter.
Okay.
All right. This is specially designed for a family of 4 to 6 members. In the capacity, okay. You can see this is KYC floating dome model. The reason why we manufacture in this model is because it protects you from bad smell and gas leakages. At the same time, the gas production that we get from here, this plant is more effective than the other digesters. All right.
Yeah. Where it can be installed, sir? Like I may not have a huge area, let's say, but can it be installed on the rooftop?
Exactly. You can. It is more like a water tank that you set up on the top of the terrace, right? You can you can place this on the terrace and give the pipe connection to 3 floors from terrace. You can go to the connection can go up to ground floor. The pipe connection can go to ground floor.
So the bad odor and kind of insects and all other things will be completely avoided by this setup?
Yes, it is completely. You can see it is completely packed.
Okay.
The plant is very simple, ma'am. There are 4 layers in this. One is intake, all right, wherein you dispose the waste, the entire waste that you get from kitchen. Suppose you're getting there for a family of 5 to 6 member, max to max you get about 1.5 to 2 kgs of waste. All right.
Correct. Yes.
You get a waste of 1.5 to 2 kgs. You have to mix that with 1:1 ratio of water.
Acha. Every day I have to do the same thing.
Right? It is more like, instead of it is an advantage for us to keep our environmental safe. First thing. Second thing is that we are not dependent on anyone to take a waste.
Exactly.
And third thing is we are getting energy out of it.
Yes.
And fourth, we are getting manure which can be utilized for the gardening purpose. So
Okay.
basically nothing is going for waste here. All
Mhm.
instead the waste is being utilized in a way which is giving energy to us and also saving our environment. All right.
So how much what are the ways we can do the installation? I mean, do we have to complete a new repiping for this?
Uh,
Or
Go ahead, please.
yeah, I mean, because let's say I'm just now in the process of constructing the house, so I'm planning all this can be incorporated. Like we have already planned for many things, solar panels and every other things.
Correct.
So along with that, if this also can be installed at the level of construction itself, so whatever the connectivity pipings, those issues could be, I mean, taken care now itself.
Yes,
So
ma'am.
there's nothing much, or just a simple one pipeline connection is done. That's enough.
Yes, ma'am. Either way, it depends on you. Depending upon the side, we can decide that. Yes, not denying the fact that while at the construction stage, we can plan everything. We can leave a pipeline from the rooftop to the kitchen where it actually, it's supposed to be connected, and then we can plan a space to set up the biogas plant on the terrace. And if you want, if you have not planned, there are people who have already constructed houses. They can easily plan it, and we can do an additional piping for that. That's not a problem.
Okay, so that's not a major thing then.
That's
I
not a
believe.
major thing. We can
So
install it anytime that you want.
okay, and on
I
an
was
average cost, sir, approximately?
Yeah, I'll tell you, ma'am. First, I'll
Okay,
explain you
okay, okay,
about
sure, sir, sure.
this.
Yeah,
I'll
thank you.
explain you about the process. All
Yes,
right.
yes.
How does
Yeah,
the anaerobic digester actually works? There are different kind of digesters. If now that the topic has come about the family small scale plants, I'll explain you how it actually works. Okay.
yeah,
So
thank you so much.
sure. There are 4 layers in this plant, ma'am. It is very simple. You can see one is inlet, wherein you dispose to waste. The entire waste that you get that is supposed to be mixed with 1:1 ratio of water. All right, and that goes to the digester. This is the digester part that you see here. I'm pointing out the cursor, right? This is the digester part. Here, what we do is digester is installed with bacteria. So what are the type? There are 2 types of bacteria. One is natural bacteria, another is artificial bacteria. Natural bacteria. Artificial bacteria are filtered from natural bacteria, which is called as enzymes. Okay, that you generally get it in market, and which is expensive as well. All right. When we install, I'll tell you the difference of installing the plant with natural bacteria and artificial bacteria. Okay. When we do an installation with artificial bacteria, what happens is we'll have to replace those bacteria every 3 months or 4 months. That's again a cost effective. That's again, an expense. All right. Again, the cleaning of the digester, all the other things are involved in it. That's why we prefer to go with natural bacteria, which are permanent, which can easily last for 15 to 20 years. Ma'am, I can tell you that the durability of this plant, this is actually manufactured with FRP material. There are different kind of materials that the other companies uses to manufacture, but we prefer to manufacture in FRP material, which is called as fiber reinforced polymer. Okay. The reason why we use this material is because the durability of this material is much more compatible compared to the other materials. It is also tested with BTDC, that's Biogas Development Training Center, that FRP biogas plants are 10 times effective and reliable than plastic, synthetic, and polyester, which is balloon. That's why we prefer to manufacture in FRP material. And the durability of this plant will be 25 years, minimum 25 years. It will last for minimum 25 years. Okay. So I was talking about the layers. Also, this plant will be installed with huge amount of cow dung, which will actually produce the bacteria. Okay, that bacteria help us to ferment the waste and actually produces the gas. You can see the drum. So this drum is filled with the gas. Okay, so that gas is connected with the valve to the kitchen, and from outlet you get slurry. This is automated. There are no motors, no machines involved here, installed here. This is completely a natural process, which is done with the help of waste, bacteria, soil energy, and heat energy. This is something, a basic overview of the biogas plant. Anyone have any questions here?
Can you tell again the difference between natural and artificial bacteria? How long does it last?
Sir, artificial bacteria can last only for months, I can say.
This can be procured from the market?
Yes, you can, but it's quite expensive. Suppose, okay, you install this plant. I'll just give it one example. Suppose you install the plant, all right, and there is already a waste, related to this. I mean, like, you dispose the waste on regular basis. That waste is getting fermented, and you're getting slurry. Everything is working normally. After 3-4 months, the gas production is stopped and it is not getting fermented. The waste that you're disposing is not getting fermented and there are blockages. Okay, you'll have to reinstall the plant again. So what you have to do to reinstall the plant is take the top drum, take out the entire waste that's inside the plant, again put the bacteria inside it. That's why what we prefer is, once you install the plant with natural bacteria, that's cow dung, you don't have to reinstall the plant again. You just have to dispose the waste on regular basis, because the bacteria inside it will keep on adding on to it on daily basis.
How does a bacteria form a methane gas out of that waste?
I'll explain you, sir. I've got a PPT on that. I was just giving you an overview of the plant because we just happened to come across with this question. I'll explain, and I'll take you to another PPT which actually help us to understand more about the anaerobic digester and about the bacteria, okay, which are actually produced inside it.
Okay.
I'll share you a small video of a small household plant, okay, which is installed, and then you can see the quality of the flame and the quality of the methane.
I have a question. Sorry, sir. Here again, interrupting.
Sure.
Yeah. So you said I can install it on the rooftop, and on an average, let's say 1.5 to 2 kg every day, I put my wet waste, whatever biodegradable, and then whatever gas it generates. How long it takes duration, like, to fill that gas tank, or will it be sufficient that how long the process takes to entirely fill that tank, and then I can start using the gas, right? Probably. And what is the maintenance issues related to this? Like every month or 15 days, should I need to go with it to clean the entire tank? Or, I mean, I'm asking the as a common.
That's a valid question, and that's a basic question, ma'am. I was about to come on that. I'll first share your video. You will see the quality of the flame. Okay.
Okay.
And with this video, I'll explain you the questions that you have. Okay. So you can see a 1 cubic meter plant is set up behind this person, and this is the quality of the flame that we will get.
So on an average, like 1 day, or let's say 1.5 to 2 hours cooking, I can finish with this, right?
Yeah, ma'am. I'll just explain you about that.
Yeah, sure.
This is the quality of the flame.
Okay.
All right.
Looks good.
Okay. This is the quality of the flame, and yeah. So I was your question was like, how long can I get the gas, right? So this drum will lift 2 times in a day, ma'am. All right, 2 times in a day. The process is like, the gas production will keep on happening. There is no specific time that the gas production is happening. It's not like the advantages. I'll talk to you. There are some advantages of biogas plant. Okay, So once we install the biogas plant, once we install the biogas plant with back in natural cow dung, okay, those cow dung will keep on producing the gases out of it. Okay. So when we add a food waste to it, that ferments and it produces the gas. Okay. And what if we don't add the, what if we don't feed the waste? Okay, there is a time frame where like if you don't feed the waste for 10 to 15 days, the quality, suppose if the amount of gas is produced is 1 kg, okay, if you're not feeding the waste for 30 to 45 days, it will reduce to 800 grams. Okay, that's how the the ratio will keep on decreasing. All right, in 1 cubic meter for household purpose, it produces about 500 grams of LPG equivalent gas on daily basis. 500 grams is half a kg in a day. All right, that if you multiply that with 1 month, that's equivalent to a complete cylinder that you get. That's 15 kgs of gas in a day. And you can easily flame this for 1 hour to 1.5 hours in the morning and 1 hour to 1.5 hours in the evening, because it lives 2 times in a day. Basically, we cook like in morning, afternoon, and evening, batch wise, right? So once you utilize that in the morning until you use it till evening, there will be a gas production and gas formation in the plant. Again, you can utilize that, and that's how the process works. And with respect to the maintenance, one of the big advantages is that there is no maintenance in the biogas plant. There's no maintenance at all. All that you have to do is feed the waste, utilize the gas, and ensure that the slurry is coming from the output. Utilize the slurry. That's all, ma'am. That's a healthy maintenance of biogas plant.
Okay, and the safety issues, there are
Safety,
such.
yeah. You can see a water jacket, ma'am. There is a water next to the, the top drum, right? There is a water in here. This is actually a water, we say it as water jacket. This water jacket prevents you from bad smell and gas leakages. Okay, if there is any gas leakage, this drum that you see is lifted, right, will not lift to that level.
Sir, we are not able to see the, I think, the slide of drum.
All right, one second. Yeah. Is it like,
yeah,
okay now?
It is visible.
Right.
Now it is visible.
So you can see a water here, ma'am, next to the top drum. You can see the water here, right? So this water prevents you from bad smell and gas leakages. Suppose if there is any gas leakage in the top drum, the drum will not lift at all. It is basic that the gas is going on in the air. So with respect to the safety issues, there are no, we've been working from years together. But what case we have not received any issue. And in the commercial and industrial plants, we have got different machines to, for the safety precaution, use flame assay.
So now I have two important questions. One is, how often seeding should be done? That is why your artificial bacteria.
I missed your question, sir. I'm sorry.
Your seeding you are doing through the cow dung, right?
Correct.
How often? That is one question. Second thing is, how the environmental condition. If the temperature is because it's anaerobic digestion.
Correct.
If the environment, outside environment, if it is very less, the temperature is very low, how it affects on the gas productions.
All right, I'll tell you some. All right, first of all, when we install the plant with cow dung, it is only one time. We don't replace that cow dung frequently. That's why we are using natural bacteria here. We don't. Here, Am I clear? Hello?
Yes, sir.
No.
Only one time.
All right. Yeah, at the time of installation, we use the cow dung. That's all, sir. After that, we maintain the plant with food waste and the waste, any waste that you can talk about, that food waste, garden waste, animal waste, flower waste, any waste that you have in the campus. Basically, in hostels, we get food waste, and we are not utilizing it in a proper way. Okay. So what we can do, and it is also one of the, like, mandatory component of NAC to have the, waste managed within the campus. That is one of the factors.
Any approximate value of the volume of the gas productions per kg?
Per kg is 0.4 cubic meter or 0.5, so that's equivalent 0.5 cubic meter. It certainly depends on the digester capacity, I can tell you. Okay. If you're talking about 1 cubic meter, that's 500 grams. If we convert that into in the normal calculation, 0.4 to 500 grams.
Okay.
All right. And your second question was on the temperature thing, right? What if you're not having a suitable a suitable climate? So to prevent this climate issue, what we do is, so we have, let me tell you, we have installed the plant like in Jammu, Srinagar, also in Guwahati, Assam. These are the places where the temperature, moderate temperature, is below 15 to 20, right? So to prevent this heating temperature issue, what we do is we add to small plants I'm talking about. I mean like just for like domestic and commercial plants, not the industrial based. For industrial based, we've got different machines or heating systems for it. So like to domestic and commercial purpose, we add a geyser to a plant. Okay. This act when you mix the waste with 1:1 ratio of water, you can actually mix that with hot water, which gives us the normal temperature in the plant. This is just for like 1 or 2 months. When we have a temperature of minimum 15 degrees, then we are okay to use the normal water, not required to use the hot water. Am I clear with that, sir? Rajkumar, sir?
Yes, sir. Yes. Thank you.
All right. So I'll proceed with the details, more details about the anaerobic digesters. So there are 4 key steps of digester when we install the plant. Okay, there are 4 key steps that we have to for all the digesters we have to take the steps. Okay, these are the normal reaction of the digesters, I can say. All right. So when we hydrolysis, okay, there are 4 steps. One of the steps is hydrolysis. Hydrolysis is something that when we install the plant, okay, we have to ensure that we mix that with water and the waste contained the cow dung of the quality of the cow dung is good. At the same time, it is mixed properly. I'll share you a picture of can you see the tank and a dung inside it? This is how the cow dung and the water is supposed to be mixed. We have to mix that with 70% of cow dung and 30% of water. Okay, so that will actually help us to give a good amount of gas and a quality gas, so quality methane, I can say. So any questions so far on hydrolysis? The reason why I'm asking you these questions, because once we move on to the next step, the process changes. Okay, and there is a like the rule of the meeting is to keep. I'm sorry to get this up. The rule of the meeting is to keep the question and answer question like session for half an hour. If I keep those questions, when we actually come up with a lot of questions, it will be confusing to everyone. That's why I'm going step by step and asking you questions.
Hello, sir.
Yes, ma'am. Yes, ma'am. Any questions so far? Are we good to go?
Hello.
Yes, sir.
Say, what is the amount of cow dung you have to use initially?
All right. That's a good question, sir.
Hmm.
Every capacity have got different amount of there are different capacities. Okay. It starts from 1 cubic meter, 1.5 cubic meter, 2 cubic meter, 3 cubic meter. It goes on and on based on the waste that you get, the amount of waste that you get from the campus, or based on the amount of waste that you get from any society or anything. We design a capacity, and there is one more factor to design a capacity is HRT. I'll come to the topic later. All right. So based on these factors, we design a capacity of the plant. Suppose if you're getting 15 kgs of waste in your campus, okay, I will give you 4.5 cubic meter capacity of the plant. That capacity can easily intake and ferment this 15 kgs of waste or 20 kgs of waste in a day. It's a simple thing, sir. Every human have got a different capacity to eat. Okay, that's how I can tell you. My capacity is to eat 2.5 to 3 chapatis, but someone else capacity is to eat 4, 5. So every capacity of the plant is designed based on the amount of waste that they get in the campus. All right. So based on the capacity of the plant,
What is the minimum capacity?
that's 1 cubic meter, sir, that I shared the picture here.
1 cubic?
1 cubic meter plant here.
So what is the amount of cow dung required for this?
Okay, so for 1 cubic meter plant, we have to install the plant with 30 bags of cow dung. So when I say 30 bags, you get cement bags, right? Cement bags, 100 kg cement bags. 30 bags of fresh cow dung. The cow dung is supposed to be fresh initially. Okay, at the time of installation, we need fresh cow dung. 30 bags of cow dung.
For 1 cubic meter.
1 cubic meter.
It is huge, you know.
Sorry, sir.
Earlier you told for 4.5 cubic meter, 15 kg.
So that's kgs of food. I'm not talking about the food waste here. I'm just talking about for 4.5 cubic meter, to install the plant, we need 1 tractor of fresh cow dung.
1 tractor.
Yeah. This is at the time of installation and we take care of it.
Achha, so you will take care from your end,
Yeah,
right, sir?
we as a company will take care of this. Because we have got dealers and we have got people across India who can actually arrange the dung for us. And we will, that's a part of our scope, sir. I'm just explaining you because it is a process of the installation.
So this is a one-time process, right, sir?
This is one-time process, that's all. This is one-time process to reduce bacteria inside the digester. So this 30 bags of cow dung, what we do is we mix that with 1:70%, 30% of water. We mix that like it becomes like a normal paste that you can see here.
Slurry, kind of slurry.
Slurry kind of slurry. Not so much that the water ratio of the water is high. We ensure that the ratio of the cow dung is high. All right, and ratio of the water is less, and then we install it.
So whether it gives any bad smell or so?
No, sir. It does not give you any bad smell. Okay. It does not give you any bad smell as it is protected with water jacket. It does not give you any bad smell. We can do a side. I can actually, if someone's in Bangalore and have any doubt, you can ask Jyoti ma'am that we have set up a plant at Ramaya College, Ramaya IT College. Ma'am, has it like smelled any time to you? Okay, so we have installed a plant at Ramaya College, sir. It is like-
Why I am asking is, if any leakage takes place,
Mhm.
that in that particular area mosquito can develop. That will be another problem.
Okay. Okay.
Now
To
your all setups, they are made up of any polymeric material?
fiber, sir, fiber reinforced.
Fiber.
Correct, sir.
And fiber normally, when it is exposed to sunlight for a longer time, it becomes harder and harder. Let's say it may develop crack also.
No, sir. We use different layers and mats to, and
Just like
also
water tank. Just
it-
like water tank.
I cannot say like a water tank.
Now, water tank also have nowadays a number of layers they will put.
Yeah, they put layers just to increase the like, you know, thickness of the tank, but they don't add the rings. They don't add the rings. You can see there is a ring here. There are rings here.
Because it should hold a huge amount of load.
Yeah, that's why we're designing the capacity, sir. To sustain that load. We are not giving only one capacity to all to every capacity of the waste. We're not doing that. We are ensuring that the capacity is designed based on the amount of waste that they get. So when I say 1 cubic meter, you can dispose only 3 kgs of food waste in a day. You cannot overfeed this plant.
So along with cow dung, you can also use food waste also.
So that's what I'll come to that process. Okay, but I'm talking only about installation. I'll tell you when to use that waste.
Okay.
After installation, there is a process. Okay, so we have to follow that process, that digestion process, and after that is when we have to feed the waste. Okay, we are not feeding the waste along with the cow dung at the time of installation. I'm just explaining you about the installation now. So after this installation, I'll tell you when to utilize the waste so that it is good for the plant and we are not creating any blockages here. Okay, am I clear, sir?
Yeah.
All right. So when we install this plant with cow dung, all right. So after this, we fill up water here to prevent from bad smell and gas leakages. This is the water jacket column. So when we do that, after this, we will close the top drum of the plant. I'll share you a video. You can see a live demo plant video here, sir. It is closed. This is the top drum, which is closed, connected to the pipeline. It is going to the burner, and we can see it's flaming here. This is how the pipeline is connected to the burner, sir. Okay. So after that, we close the top drum. We close the top drum and the installation process is done. Okay, that is something that covers the hydrolysis point. That is the first step of anaerobic digester. Okay, any questions so far?
Sir, I have one question.
Yes, yes, sir.
After that, when we extract the gas, and there may be generate the residue material that may be there, and we have to clean it, or what we can do for that?
Sir, you're not clear, sir. I'm sorry, I missed your question.
After the gas extraction, there may be the residue material may be there. So that residual material we have to be remove, or it will be there only.
Sir, we are not removing, especially for cooking purpose, we are not removing any gases. Okay. We are just removing the water content from the pipeline.
No, sir. Sir, my question is, if we extract the gas from our reaction tank, and after that some residual material may be there, it may there, and we have to be remove it frequently, or what?
No, we not
can do that.
That's what, sir. There are no, I mean, like, after getting the gas, you're talking about the waste that is fermented inside the plant, right?
Yes, sir, correct.
That's what, sir, that becomes a slurry. Okay, that becomes a slurry. You will automatically get that from the output of the digester. You don't have to do anything. So when you get it from the output of the digester, all that you have to do is you have to mix that with 1:3 ratio of water and dispose it for the gardening.
Okay, so that having smell or nothing?
That will not smell until you dry it. So the ratio of the methane is 80% of solid, 80% of liquid and 20% of solid. So as long as you don't dry it, people dry it for selling that in the market. Okay, there are dryer machines for it. Okay, you cannot dry it in the smaller capacity. That has to be an industrial plant altogether. All right, you cannot dry it in the smaller capacities. You can mix that with water. It will not smell 100% as long as you don't dry it for 4 or 5 months. If you've just laid it down somewhere, it is there for 4 or 5 months and it is getting dried, that's when it smells. So until then, it will not smell.
Okay, sir.
Okay. Are we good on this, sir? Okay. So the next step of the digester is acidogenesis. Okay. So what happens is, so when we install the plant, okay, with cow dung, it starts producing the gas immediately. Okay. So it starts producing the gas immediately, and that gas, it's not supposed to be used. Okay. The initial gas is called as acidogenesis. The reason why we don't use it is because the ratio of the carbon and the other gases are more compared to methane. Okay. So what we do is we leave that. So there is a time frame, especially after installation. Suppose I install the plant today with the cow dung. So after 3 days, okay, within 3 days, the entire drum will lift it to its max. Okay, so the gas production will reaches to its max. So that once it reaches to the max, once the drum lifts it to its max, we have to release the gases. So those gases are called as acidogenesis, the first process, okay, of the installation. So once we install, after installation, we don't use the gas directly. We have to purify it. And how we purify it? There's a time frame. So once we install the plant, within 3 days, the drum will lift to its maximum level. So when it lifts up to its maximum level, we are supposed to leave that in the air. So that is called the first process of the second process of anaerobic digestion, second reaction of anaerobic digestion, I can say. So that's when, you know, the gases are supposed to be left. Any questions, sir? All right. So the third step is, yeah.
Sir, this step, will it be monitored from your end as a part of installation? The
Yes,
second
ma'am.
process.
It has monitored everything. You can see the technology is like way too fast. Suppose I install the plant at like a different location, okay, it's not after installing the plant. I will ping you on daily basis to send me the picture of the current status of the plant. To send me what is the how much is the drum lifted. Okay. So when it is lifted to its max, I will tell you, ma'am, release the gas. So how we release is just open the valve. That's all, and leave it for 2 minutes. The drum will automatically come down to its maximum level, like to the minimum level.
Okay, so
And it
that
is
means
monitored.
I need to monitor as a customer end level. I need to keep monitoring that level, whether it has reached to a certain max volume, right?
Ma'am, it is a process of installation, I can say, when you have to help us a little. If the location is nearby, we definitely drop into your place and we check. Okay. But if it is like in different state, what we do is we ask clients to send us basically it happens like there's one person who will take the responsibility of the maintenance. Okay.
Okay.
Everywhere
Yeah.
we go, there is one person who takes the responsibility of the maintenance. Okay.
Okay.
So
Okay.
we take the contact person of that person, contact number
Yeah.
of that person. Okay.
Yeah.
After installation, we will explain the entire process to him. How to maintain. We will also share the manuals. Okay.
Mhm.
How to maintain, how to actually, utilize that, what are the, advantages. Everything will be explained to them.
And the services are very readily available if any issues.
Some, ma'am, being in Bangalore, we supply, do the servicing till Jammu,
Okay.
till Vizag, till Guwahati, Assam. By God's grace, we are supplied throughout India.
Okay. No,
Right.
why I'm asking, because this is the main things what we face day to day
Exactly.
life, right?
It's not just
Tomorrow
that. It's not just that. We also have dealers. Okay.
Okay.
In
Okay.
specific places. I mean, like in all over states, where we've trained them how to maintain it. Just in case if anything happens, we ask them to travel. We ensure that it's been taken care.
Okay. That's good. Thank you.
All right. So this is the first step. So there are 3 steps that are supposed to be followed after installation. One step is acidogenesis, where at the initial from installation to 3 days, the gas will be produced and it will automatically, released in the gas. Again, so when we close the valve, the second process of acidogenesis starts. Again, the gases like here, the gases are little like the entire, I mean, like whatever the gases, the waste that we have mixed with 70% and with 30% of water, right? That gets fermented more. So the ratio of the mixed waste will be fermented and it is more pulpy than what we have installed. So it is like the digestion reaction is already automatically started. Okay, so when the digestion reaction is automatically started, we are getting the gas. So we have released the gas again. After 3 days of the second time, we will again have to release the gas. Okay, in those gases, all the other contents, like suppose after installation, the ratio of carbon is 70% and ratio of methane is 30%. So after releasing the gas for first time, that's acidogenesis, ratio of carbon becomes 50% and ratio of methane becomes 50%. Okay, so here we are at the stage of 50%. Again, the gases are released open, and like there is a formation of the gas. So when we release the gas at the second time, the ratio of methane is 60% and the ratio of carbon is 40%. Okay, so after 3 days, again we will open the valve and leave the unwanted gases in the air. We're not utilizing that. So that's how we do the process for 3 times, so that we get purified methane gas at minimum of 65%, so that it is in the flammable stage. So these are the first basic steps of hydrolysis is basically installation. Acidogenesis is basically the gases, unwanted gases that is produced, and the filtration of gases becomes more complex than what it was at the time of installation. And acidogenesis is also one of the part of it, where we get more purified gases, and then methanogenesis is where everything is considered. If it's in the stage of flammable, we will definitely flame it. Any other questions here? These are some basic steps that we have to take, and also it is how the anaerobic digester reacts. It is a common thing in all type of digesters.
How many days are required to use the gas? 3 days?
9 days, sir.
5 days?
9 days.
So,
9 days.
9 days.
First step is 3 days. Second step is 3 days, 6, and third step is 3 days, 9. After 9th day, we can utilize the gas.
Okay. And can you say again, in hydrolysis, hydrogenesis, methane is 30%, acidogenesis 50%, acetogenesis is 60 or something?
So hydrolysis, when we install the plant, the content of the methane, it is just like 20 to 30. Okay, if the quality of the cow dung and the temperature is good, like 30 to 35%, like I said, everything is mattered here. Temperature, quality of the cow dung, also the soil energy. If we're getting this all three, okay, the quality of the methane in the initial stage will be 30%. All right, these are the rough figures that I'm giving you. All right,
and so acidogenesis?
Acidogenesis, the quality of the methane will be like 40 to 45%.
Okay. And
okay.
After that?
50 to 55%. And after methanogenesis, we get the methane, like purified methane, which is actually in the flammable mode.
Okay. Okay.
So it does not depend on the capacity, right, sir?
No, no, it does
capacity?
not. No, it does not. It is a normal.
It's a 9 days, approximately 9th day onwards.
Yeah, it is a normal anaerobic reaction that every a digester will take this. We need this 8 to 10 days, 9 to 10 days for purification of the gas.
Now you have mentioned about while saying about what are the gas output.
Yeah.
Say if it is 50% methane, then you said 50% carbon. What do you mean by that? Carbon.
Carbons are like, when we say carbons, sir, it is like unpurified gases. Okay.
So methane also contains carbon.
So unpurified gases are more. Like the value of the carbon, yes, I agree that methane is methane also contains carbons, but the value of carbon is low compared to methane. That's when it flames. That's when we get blue flame. When I showed you the video, you can see the quality of the flame is blue.
Blue, that is the initial stage.
Exactly. That's the initial stage. Okay. So as and when we start feeding the waste, the quality of that flame increases when become more purified.
Colorless, almost colorless.
Exactly.
Because what happens is the bottom of the vessel will be deposited with the carbon.
Right.
Yeah. Say now in LPG, we cannot find any such deposition under the vessel.
Correct.
Yeah.
So that's how, sir.
Okay.
So after that, temperature, requirement of the temperature of the time of installation. Okay. Requirement of the temperature is minimum for the good fermentation. Okay. Someone had a question like, what if the temperature is not good? What do we do it? Like I told, like we will use hot water for the good fermentation. Here at the time of installation of the plant, the minimum requirement of the temperature is 20 degrees. we minimum require 20 degrees of temperature to install the plant. After installation, if the requirement is, if the temperature is not good, we will get the gases, but they will be a little delay because since we have not purified it, since the gases are not purified, not in the flammable mode, then we will get a little less quality. Instead of 3 days, it will take 4 days to lift the drum to its maximum level. If the temperature is good, the drum can lift within 1 or 2 days. Because temperature is one of the main factors, because we are not using any machines or any mechanism for this process. Everything is dependent on nature, waste. So here, temperature plays an important role for the digestion of the waste. Any questions on temperature?
Sir, I have a question.
Okay.
Yes.
Okay, so when you have your digester inside it, how do we ensure that it has reached to the required temperature levels? So suppose today it may not reach to that temperature level, maybe tomorrow it is reaching to that. So the amount of maybe the variation in the reaction process and maybe the production of the gas, what you're trying to say, may vary every day, probably.
All right. Ma'am, when I talk about the temperature, I'm talking initially at the time of installation. Okay. So if the temperature is good today, so basically in real-time scenario, okay, in real-time scenario, you place an order to me. Okay. Just a minute. You place an order to me. Okay. And you will tell me, Syed will do installation on Tuesday or Wednesday. Okay. Or maybe after 2 days. So we will get to know like what is the temperature. Okay. If we are not having the required temperature, we will definitely delay the installation. Okay. We will delay and we will tell you, ma'am, it's not a good time for installation. The temperature is not good. So we will delay the installation. Okay. So for the required temperature. So now everything is going fine. We have installed the plant. We are you're disposing the waste on regular basis. Okay, you're disposing the waste on regular basis. Just a minute now. Just I'm sorry, I just got a little emergency call. All right. So I was talking about the temperature, right? If suppose if everything is working fine, okay, like we've done with the installation in the good temperature, we've started using the gas, we have purified it, we have started feeding the waste, we are utilizing it on regular basis, and the temperature automatically drops in, right? So if the temperature drops drastically, if because of climate condition, that's when we ask you to like use while disposing the waste. That means when we are utilizing the gas, we are automatically utilizing the waste. I mean, like disposing the waste. So when we dispose the waste, we will request you to dispose it with hot water so that the temperature is maintained in the digestion. So that will not affect the gas production.
Okay. So then how do we decide? I mean, just looking at this climate, like today is a cloudy climate, then when I'm disposing my waste to the digester, I have to then take a hot water and then mix it along with that. And then I have to, supposed to insert inside the digester. Is that way? Just looking around the climate conditions?
Yes, ma'am. You will definitely get to know if it's little sunny in the morning, then there is no problem. If it's like raining continuous for like 6-7 days or maybe for 2 days, then we will request, we as a company will request you, utilize the waste, dispose the waste with.
Okay. Okay, sir. Okay. Thank you, sir.
Any other questions on the temperature part? All right. The next topic here is hydraulic retention time. All right. This is one of the major topic that I wanted to actually discuss about in this platform. This hydraulic retention time matters a lot, and is one of the main factor that we actually design the capacity from. All right. When I told you that we design the capacity based on the amount of waste that you get on regular basis, right? So this capacity is basically designed considering hydraulic retention time, HRT. Okay, HRT is something that we've got three types of HRT here. One is 30 days HRT, another is 40, and 55. So hydraulic is HRT is something that the fermentation that happens inside the digester is HRT. All right, when we start using the waste and the waste start fermenting, right? That fermentation process is HRT. So considering the climate, HRT can happen in 30 days. So if I'll just show you a demo that I have here. Okay, this is the demo plant. I hope everyone is looking at this. Please confirm me so that I can adjust the camera accordingly. All right, so this is a complete biogas plant which has got inlet, digester, top drum, and outlet for slurry. Inlet for feeding, digester for bacteria and fermentation. Top drum is for gas, fourth is for slurry, output is for slurry. So here, I will remove this. Here, you can see there is a gap here. All right. Can you confirm me, ma'am, please? Can someone please confirm me if I'm audible and everything?
Yes, sir. You are audible, sir.
Yes, sir.
Yes, sir. Yes, sir. Very much. We can see also.
All right. So sorry about this. Okay. Here you can see we have divided this partition of the digester with two things. Right. Am I clear on this? As long as we don't see this, we will not able to understand this point. That's why I've kept this model here.
Yes, sir. We can see.
All right. So the below digester part is divided with two parts. One is input, another is output. Okay. So when we feed the waste, okay, from here, it is going to input. Okay, it goes to the input part, okay, and it gets fermented. So it will take 15 days for here to get fermented. If the HRT is designed based on 30 days, okay, so it will take 15 days for this to get fermented in the input. So for a brief example, if I put chapati inside the inlet, all right, so that chapati becomes like it gets fermented in 15 days. All right, am I good? All right. So if we dispose chapati, or let's take an example of any hard particle, a bone generally takes like 60 to 70 days, like because it is a hard particle. I'll explain you what to do, how to reduce the HRT, how to reduce the big mass amount of waste to the pulpy one. Okay, so if I dispose the chapati inside the inlet, it is going to the input part of the digester. Okay.
ಇಲ್ಲ ನಂದು F&F ಲ್ಯಾಬ್ ಇತ್ತು ಸುಮ್ಮನೆ ಜಗಮ್ ಸರ್ ಇದ್ರ ಅಯ್ಯೋ ಮತ್ತಲ್ಲ ಹೋಗ್ಬೇಕು ಸರ್ ನಾಕ್ರೂಮ್ ಹತ್ರ ನಾಕ್ರೂಮ್ ಹೋಗ್ಬೇಕು NBA ಮಾಮೂಲಿ ಫೈಲಿಂಗ್
Tejas, see, please mute yourself.
ಅಂತ ಹೋದ್ರೆ ರೆಡಿ ಆಯ್ತು ಮೇಡಮ್ ವಾಪಸ್ ಬಂದು ತಲೆ ಬಾಚ್ಕೊಳೋದು ಇದೆಲ್ಲ ಮಾಡ್ತಾರೆ ತೆಗ್ದಾಗ ಹೋಗ್ಬಿಟ್ಟಿದ್ರೆ ಏನ್ ಕತೆ ಸಮಸ್ಯೆ ಎಲ್ಲಿರೋದು.
Dear participants, please mute yourself while the speaker is talking.
Okay, am I good? I'm like, are we good to start again? All right. So I took an example of chapati. Okay, if I take chapati and dispose here, it goes to the, you can see that there is a gap here. Okay, it goes to the input part of the digester. All right. So when it goes to input part of the digester, it starts, the bacteria starts fermenting it. Okay, they start fermenting it because they've got food to eat in general. Okay, they've got food to eat. They've started, fermenting it. That fermentation, once it happened, it becomes solid, a little solid. It goes to the output part of the digester. Okay, in output, it will be there for like 15 to 20 days. And after that, it becomes a slurry and it will automatically come from the output part of the digester. This is the best example that I can give you about fermentation and based on the HRT. Any questions on this? I'll explain you more about this. Any questions so far?
Sir, it means HRT minimum you required 30 days for the fermentation, means for the gas production.
No, sir. Yeah, I'll tell you how the HRT is derived. There are 3 types of HRT for India, for the entire country. From MNRE, from Ministry of Renewable Energy, we have got 3 stages of HRT. Okay, one is 30 days. 30 days is where the temperature is above 30. Okay, when the temperature is constantly above 30, the food will get fermented within 30 days and it will come out of the slurry, out of the plant. It becomes slurry and it will come out of the plant. If the temperature is little low, okay, like if I have to talk about north Rajasthan, temperature in Rajasthan is above 30% in most of the time. Like considering 9 months in a year, the temperature is good. I mean, like above 30. There, the 30 days HRT will work on regular basis. All right. Second, South India. If I have to talk about Bangalore is considered in 40 days HRT because the climate here is moderate. It goes above 20. It is not less than 10 or 15 every time. It is not less than 15. So above 20, it reaches to 40 and it reaches to 35 as well. Right? Maximum it reaches to 38, 40. And so that's how, looking at the place, considering the place factor, we designed the HRT as well. And 55 days HRT is considered for like Northeast place, Kashmir, Jammu, in all these places where most of the time climate is less than 15 to 20%. That's why we can consider 55 days HRT. Based on that HRT, based on the amount of waste, we design there is a formula for it. We run that formula and we will tell you, sir, for this amount, for this place, this capacity of the plant will be suitable for the life, for the good, digestive system.
It means that your HRT, when you decide 30 days or 40 days, so your reactor is a batch reactor?
Yes, sir, correct.
It's a batch reactor.
Correct, sir.
Because once the food start decomposing or degrading, when it undergo biological decay, there should not be any continuous feeding, because there should be some kind of once we feed the waste, we should maintain for 30 days is required for the complete fermentations. If every day if you start adding the food, so then the older one already fermented and the fresh one, it needs again another 30 days.
No,
so when
sir.
it is mixed with.
Correct. So when the older one is fermented, and I'll give you the example here. When the older one is fermented, it is automatically coming from the output. It is not staying inside the digester. It is not staying inside the digester. So when we design, we give a buffer of 20% of the capacity. Okay, 20% of the capacity that can withhold inside the digester. Suppose I feed the waste, the pressure is going to the inlet. So from inlet, the fermented waste will automatically, with the pressure of the waste, that will automatically go to the outlet. And that pressure creates, and the fermented waste will automatically come out from the output. So the waste that is already there inside the plant, which is the fermented one, it is already coming out of the digester. So that's not inside it.
Sir, I have a question here, sir.
Please.
Yeah, what is the quality of your waste, sir? I mean, the waste which is coming out of your digester. How, I mean, is it, suppose it may become a cumulative 2-3 days, I leave it like that, and if I don't get it outside, does it really have a nutritional values inside it, sir, still?
I'm sorry, ma'am, I didn't get your question.
So the quality, the nutrients, what is present inside the waste, what is coming out of your digester, is it a really, I mean, a good quality one? Or, I mean, suppose if I leave those waste inside the digester and it will stay there for more than 2-3 days, so will it still retain its nutritional, I mean, the qualities or nutrients, what is supposed to have in that waste?
Yes,
and it's
ma'am.
suitable for still for the purpose of any other gardening?
Yes, ma'am. It is. When I say it is a good fertilizer, there are a lot of components inside it, like not much of acidic. Okay. Not much of acidic. Even if it's like fermented one, even if it stays inside the digester for 10 days, there won't be any harm to the bacteria, because bacteria is fermented. Okay. And when it comes out, automatically, it's not that we are letting it stay inside the digester. We are not.
So does it, the system allows it to come automatically outside, or
Yeah,
we
that's
have to
how the
manually
system
take
is
it out?
designed. That's how the system is designed. We cannot definitely ask our users to, go take
go
out
and
this
manually remove these things every day outside.
manually. We cannot ask it. We cannot ask them, ma'am. The system is designed in a way that it will automatically come out. And when it comes out in a liquid form, all right, where the liquid percentage is 80 and solid percentage is 20. You can easily, put it like, pull that, like you can keep a bucket basically. I'm just giving you an example. If you have a small plant, okay, you can keep the bucket here, like below this output. Okay, you can keep the bucket. When the waste comes in, right, the waste will automatically be dumped in that bucket. You can put that, like, take that bucket, utilize it for gardening. And if you don't want to utilize it, and if you don't have a garden, you can easily supply to the sanitary pipeline. That's not harmful.
Okay, thank you, sir. Thank you.
So that's how the HRT is designed. So anywhere, like where the temperature is good, based on 30 days HRT, the plant will run successfully. If we have a moderate temperature, 40 days is for South India, and for Northeast and all the other places, we prefer to keep 55 days HRT. Any questions on this?
This is the optimum HRT what you have obtained for your reactor, is it, sir?
Sir, we use it for like 40 days HRT. That's a moderate one that we prefer.
Yeah, some reactors, it is designed in the market based. You have the reactor is designed based on the HRT. Some reactor is designed based on the organic loading rate. or the surface loading rate. So what is the amount of kg of waste which you are applying per meter square per day? That is the organic loading rate. So some reactors are working on the organic loading rate.
That is also one of the factor that we look at, sir. It's not just HRT. That is one of the factor that we look at. I'm not giving you, for example, I'm not giving you, even if it gets fermented in 30 days, I'm not giving you 1 cubic meter plant for 15 kgs of food waste. I will tell you for 15 kgs of food waste, you need to go for 4.5 cubic meter plant because the capacity of that plant is to handle that waste. So first thing is we look is for the amount of waste. Second, consider the HRT. And third, those are two main factors that we look at. It's not just HRT. Feeding waste is also one of the main factors that we look at. Amount of waste, I can say.
And the bacterial residential time, particularly when we cow dung, when it is in fresh, the bacterial growth, the bacteria, the decomposition initially will be in a lag phase. It will not come in a log phase or in a logarithmic scale. The rate of decomposition initially it is initially will be less. It needs some time bacteria to adjust to the climate, and then it has to start its decomposition once it is adjusted to the environment. That is in a logarithmic growth.
Correct, sir. Correct. That's why.
That is why the quality of the cow dung and the bacteria which is present is also most important while feeding the cow dung.
Exactly, sir. That's why I showed you a picture of a good quality of cow dung, which helps us to understand more, because I have faced these scenarios in real time where when I tell a client that we need fresh cow dung, they happen to assume it like, okay, fine, even the 10 days of the cow dung is fresh. So we give them this criteria that we need cow dung within 3 days of, like we need cow dung which is like within 3 days of fresh cow dung.
And which is also one of the important factor when we, especially food waste is concerned. When we throw something which is like orange, the waste, other things, the pH which is in acidic range. So when we add those food waste, the automatically pH of entire things will come down. Automatically the fermentation will get affected.
Correct. So that was my next point, sir. You can see on this screen that I was going to talk about the feedstocks that we are going to give. There are a few things that we need to avoid. If you allow me, I can probably drink water and explain.
Okay, sir. Okay. Thank you. Nice presentation.
Just a minute. I'm sorry. Thank you. Yeah. So suppose now we have installed the plant. Okay. So when we install the plant, now the the gases are released. Now we are in the usable mode. Okay. What we tell you is, right, I did not tell you, you must have noticed I did not tell you that we need to start feeding the waste that right after installing the plant. So the right time to start feeding the waste is, suppose 10 days we generally take for fermentation. Okay. So after 10 days, we tell you like give the gap for 2 or 3 days, then so that the bacteria is inside the digesters. So when they like at the time of purification, they almost get settled with the temperature and everything. Okay. So now after 12th day, we would request you to start feeding the waste. So how do you feed the waste? So like I took the example of 1 cubic meter where we can dispose 3 kgs of food waste maximum in a day. So on the 12th day, we will request you to start feeding the waste. So how do we feed the waste? So like I said, we have to mix that with 1:1 ratio of water. And the first week of the feeding, we will not ask you to dispose 3 kgs maximum. No, we will tell you start with 700 grams in the first week. Second week, go drastically increase the amount of waste that you are disposing on daily basis. So it helps us to, it helps the bacteria to get adjusted, start fermenting in a way that it is not overloaded. Right, Rajkumar sir? Am I clear on this?
Yes, yes, sir.
Okay.
I will put somewhere the summary. I will ask one aspect questions at the end.
Sure.
For, and operation and maintenance cost.
I'll definitely give that to you. I've got that. Not just this. I've got different usage of the gas as well for you guys, and that's interesting. Trust me.
Yeah. Let me see that we are looking also for our campus. Let me see.
Sure, sir. Sure, sir. So the feed, okay. So when I talk about the feed, there are a few things that we need to avoid, okay. Here, any biodegradable waste can be utilized here, okay. Such as animal waste, we get cow dung. With cow dung, at times feed of the cow dung is also included. We just can't ask the maintenance people. I mean, like if and someone has got a cow dung or cows, when they receive the cow dung, they mix that, the maintenance people mix that with feed of the waste. That's okay. Okay. So animal waste is fine. Food waste. Okay. So when we talk about the food waste, okay, there are a few things that we need to avoid. Okay. One is coconut shell. That's not a degradable product. Another is eggshell. We're not supposed to dispose the eggshell. Onion peels we have to avoid. Okay. Onion peels are supposed to be avoided. Lemon, which any food which creates citrus, we have to avoid that. Like Rajkumar told that creates, citrus is not good for bacteria. That actually destroys the spoils the bacteria, and it is not good for the fermentation as well. Okay, there are a few things that they have to, like, maintenance people have to avoid it, and then they're supposed to dispose the waste. Any questions on this? Okay. All right. So if you don't have any questions, on the feeding part, I'll tell you what is the healthy way of disposing the waste. Okay. Especially in the industrial level, or maybe I can tell you like the hostel level as well. All right. So when we get waste in hostels, all right, so we get different kind of waste, like vegetable waste, leftovers, all right, vegetable waste, leftovers, bones. Just a minute. All right, I'm sorry, I'm really sorry. We can you get different qualities of waste. Like, one is food waste, another is vegetable waste, bones, leftovers, and all the other kind of waste. Okay, so how do we make sure that it is not creating the blockages of the waste? Okay, it is not creating the blockages of the waste. So what we do is, crushed and it becomes in the pulpy form, so that it is easy, like, when we dispose in the plant, it is easy and does not create any blockages. And at the same time, when the waste is really chopped, I mean, like really crushed, the fermentation becomes more like active, and fermentation is good. Questions on this? Any questions on this? Are we good, sir?
No, sir, you can continue.
So when the waste is crushed and disposed, the quantity of the waste increases drastically. Example, all right. It is, when I say it is good for fermentation, all right. If I am eating something, if I chew it properly, it gets like, digested quickly, all right. And if I eat something which is not chewed properly, the digestion takes a lot of time. That's how the human reaction is, all right. Similarly, when at the time of disposing the waste, if the waste is chopped or crushed properly, the fermentation of that waste is like becomes like it's fast. And the waste, if the waste is in the pulpy form, the fermentation of the waste is fast. Okay, it becomes faster, and the quality of the gas that we will get a good quality of the gas, I can say. And while at the time, like while installation, we will give the in the manual, everything is mentioned as to what to dispose, what not to dispose, and steps. Everything will be mentioned in the manual. All right. So we've got this. This is something that I was talking to you about, domestic. I'll just share you a video of a commercial plant where you can see the quality of the flame and the complete plant, a demo of the plant video, or I can say a setup. I'll share your video. So this video is of 30 kg food waste biogas plant. This is the quality of the flame that you will get. Okay. And you can see there is a booster pump machine. Okay. This booster pump machine helps us to increase the quality of the flame. Yeah. This is the booster pump machine. Okay, this booster pump helps us to increase the quality of the flame. This is natural gas. The pressure of the flame is not good. Okay, not be good, and we have to increase that pressure with the help of machine, which is called as a booster pump. Okay, and we give UPVC pipe connections. You see a pipe connection and valves, everything is set up by us. We will give you UPVC pipe connections with the moisture traps in the pipeline to reduce the water content. This is the moisture trap that we have. Any water content in this that going along with the gases which is going in the pipeline can be reduced, removed from this moisture trap. Any questions so far? Okay, so this is how the pipeline is going. We've got a valve here in the pipeline, and this is the top drum. This is the inlet part of the digester. Okay, digester, top drum, water jacket. And the output part. You can see there is a tub, a bucket placed for the collection of the slurry. This is a small video of.
Sir, I'm having a small doubt.
Sure.
Actually, you said booster is it should be provided next to our outlet. Okay. What is that booster content? It's a natural gas, you said. How to fill that natural gas?
No, that's the booster pump is just to just 1 minute. Hello. Yes,
Yeah.
ma'am. The booster pump is a machine, okay, which is set up, which is actually kept near the burner. Okay, it runs with the help of electricity. What it does is, okay, it pulls the gas, okay, from the pipeline with certain amount of pressure. Like different capacities will have different amount of booster pump set. Okay, for 30 kgs we have set 1.5 cubic meter compressor. So this compressor will pull the gas in that set capacity. Okay, 1.5 in an hour. So that compressor will pull the gas in that capacity and release the gas in a pressure, so that the gas is passing through the pipeline to the burner is in that specific range.
Mhm. Okay.
Sir, you are telling that the pressure of the gas is not up to the level.
Because this is natural gas, sir.
No. My question is actually,
Mhm.
say your gas producing plant should be very near to the stove or where you are using that particular gas as the fuel.
So
you can
every capacity, like I told, for domestic purpose especially, okay, we prefer to give pipeline till maximum 15 meters. For domestic, when I say domestic, 1 cubic meter, 1.5 cubic meter, and 3 cubic meter. 2 cubic meter, I'm sorry. These 3 plants, we don't use compressors. Okay, booster pumps, basically. For these plants, we would request to keep the plant within 15 meters from the burner. Okay, that's a good, a pipeline ratio where I can tell you we will get a good gas, okay, good pressure of gas, because we are not using booster pump. If we are using a booster pump above 3 cubic meter plant, we use a booster pump. If we are using a booster pump, we can keep the pipeline up to 30 to 40 meters.
Okay.
Any questions on this? All right. So we have got different, like I told you, the entire, like so far, the anaerobic, we have explained, we have covered anaerobic digesters. So I'll talk about something about different types of digesters. It's basically, I can tell you different designs, which everyone have come up with different level of, like different kind of designs for anaerobic digesters. One is a fixed dome model. You must have seen in older days we used to have a fixed dome, one fixed biogas plant, okay, where we're disposing the waste, and from output we're getting the slurry, and the pipe, we will give one pipe connection on top of that plant. That gas directly goes to the burner. That's a fixed dome. Floating dome is what we saw now. There is one more digester, which is UASP. The abbreviation of UASP is upflow anaerobic sludge blanket. I'll share you one picture of this so that everyone's on the same page. And I'll share about one KYC commercial plant, picture of KYC commercial plant. This is one ton capacity food waste plant that we have set up in Chenpatna Municipal Corporation. So the entire waste that's that's been collected in Chenpatna is disposed here in this biogas plant, from where we're producing the electricity. I'll come to that electricity part later. All right. So this is one of the plant that we have installed at Chenpatna Municipal Corporation. 1 ton per day food waste plant where we are producing the electricity. That electricity is utilized for the street lights and running the motor. Okay, so this is a KYC floating down model. Digester floating down. There is inlet and outlet. I'll share a video of it.
You showed 1 meter cube of plant previously, and that 1 meter cube is the gas for what amount of time?
1 cubic meter is the capacity of the digester, sir. The capacity of the plant, the gas that 1 cubic meter plant will produce is 500 grams. So which, like I told, it can be burned for like 1.5 to 2 hours in a day.
And considering hydraulic retention time of 40 days, if the feedstock is animal waste and if the feedstock is vegetable waste, that is kitchen waste, what is the total capacity of the drum?
Okay, so now we are talking only about the food waste. Okay,
right.
Waste is a mixture, like if you're giving animal waste on regular basis, okay, it is good. It is good for the plant. But if you don't have the animal waste, if you're running the plant with food waste, yes, the capacity is to feed in 1 cubic meter 3 kgs of food waste in a day maximum. All right, and which produces 500 grams.
Okay. Okay.
Okay, so I'll play a short video of this KYC floating down plant. So, yeah. Is the video clear? Okay. This is the output part of the digester where you get slurry from. Okay. These are some equipments used for purification of the gas for electricity. Okay. This is the digester part of the plant, which is anaerobic. Here you get the gas. That's a top drum. You can see a pipeline which is connected. Here there is a genset which is set up with electricity. This is the input part of the biogas plant where the waste is fed from. Okay, and here this is a crusher machine. Like I told, if the waste is crushed properly, it is good for the fermentation and the quantity of the plant waste can be increased. Okay, so here the entire waste is disposed in this crusher. This crusher will crush the waste, and from this part it will supply the waste to the input. From input it is going to the digester. From digester it produces the gas. The process is like I explained, is the same process. Any questions on this so far? All right. So there are different type of biogas plants. So we have covered fixed and floating. And the third is, like I told, it's USB upflow anaerobic sludge blanket. This is the updated version of fixed dome model, I must say. Okay. So here, I'll show a picture. Sorry for the delay, just a minute. Okay, this is UASP anaerobic digester. Okay, this is like a complete automated plant where there are different machines involved for feeding the waste, and the process is completely like different in this. We've got from inlet, there is a feed pump machines. From feed pump, the feed is going to the digester. From here, from outlet you get slurry. Here you can see this is a scrum breaker machine which actually breaks the scrum. Okay, which is formed. I'm not sure how to say this.
Search to plus mark.
Once again, I'll zoom this. This is a scrum breaker machine. Basically, in fixed dome, what happens, USB, what happens is when you install the plant with cow dung, the formation of the cow dung creates a scrum on top of it. Basically creates a layer of the cow dung on top of the digester. Okay, this plant, this machine helps us, to break that, layer of that cow dung, and also the fermentation, the waste will be mixed properly, then fermentation happens. Questions on this?
Now your reactor, it is a UASBR.
Sorry, sir. This is a USB reactor, sir.
Which is it's your company, which you have developed.
Yes, sir. We have got, no, this is not installed by us. We have got a purchase. There is an ongoing project we are doing with Rohan Builders. Okay, where we are setting up the biogas plant. It's under construction. That's why I didn't want to give you that, reactor picture, so that, it is little confusing because it's in the manufacturing state, but we are manufacturing this for electric purpose of 1,500 kgs of food waste in a day.
No, my question is whether it is already in the commercial stage or it is in the research stage.
It is already in the commercial stage. There are many biogas plants with USB models installed. There are different kind of different companies are doing this, and we are also into this.
So in this, we can reduce the space. The settlement, sludge settlement can be done at the bottom itself, and the gas collection can be done at the top. That is the UASPR.
No, sir. This requires more space, I can tell you, comparatively. Because I'll show you a flow chart of USB model, okay, which helps you to understand the equipments that we require to run the USB model, okay. And second thing, this is quite expensive compared to the other digesters. Quite expensive. I'll show you a flow chart. First, I'll show you the different kind of reactors. Post that, I'll show you the flow chart, how it actually works. Okay. What machines do we require to run these flow charts? I'll show you that. So this is USB is one of the model, and this is containerized biogas plant. So we have installed this plant, I can tell you. Okay, this is containerized biogas plant. So this actually helps us to reduce the space. If we have any space constraints, we can set up a containerized biogas plant, and the reactor system is same. I can tell you just the way how the USB model reactor works, right? Similarly, it is a similar reactor. It's just to reduce the space. We have come up with this containerized biogas plant. Below is the digester part. Okay, on top of it, this is a balloon where the entire gas is stored. From balloon, it is going to the other machines. Like this.
Syed sir,
Yes, yes, sir.
there's
Please
been a
tell me.
shortage of time.
Yeah.
Can we will just wind up in a couple of minutes, 2
Sure,
or 3
sir.
minutes? Thank you, sir.
Sure. Any questions on this, sir? We're almost done. Just that I have to explain the process of flowchart of the USB models, and I think we're almost done there.
Because the other speaker, the next speaker is waiting, sir. That's why.
Right, it's 11:21. I'm sorry. All right. So we good, sir, so far? Okay. I'll just quickly explain you the flowchart of how the USB and containerized biogas plant works. Can you see my screen? Yeah. This is the flowchart of the electricity plant USB model. I can tell you. Okay, there will be a collection center for USB and containerized biogas plant where we collect the waste, and after that it goes to a shredder machine. That's basically a crusher. When it is crushed properly, it goes to pre-treatment inlet. That's a feed inlet tank. Okay, so when the feed inlet happens, okay, so it goes from feed inlet. We'll have a feed pump machine. From feed pump, it is going to, we will pull that with the help of feed pump machine. The waste is supplied to the main digester. Okay, so from main digester we'll have a gas. Two things that's coming out from the digester. One is slurry that will automatically supply to the slurry output. That slurry, for that slurry we'll have a slurry pump machine. We will pump that slurry. If you want, you can utilize that for gardening purpose, or you leave it for sanitary, and you can add a slurry dryer machine for drying that slurry. Okay, so now where the gas is stored in USB and containerized biogas plant. The gas is stored in balloon. We will add on a balloon to it. So from balloon, we will supply that gas, the entire gas that is produced from the digester. It goes to the balloon. Okay, it's stored in the balloon. From balloon, we'll add a blower machine. Okay. From blower, we'll have scrubber machines. These scrubber machines will help us to remove the H2SO, hydrogen sulfide value, and all the other H2S values. Okay, so H2S value and all the bad gases from the scrubber. From the pipeline, it goes to the moisture trap, and we'll have a flame arrestor for the gas product, for the safety precautions, and from there we will supply this gas to the genset. We've got different capacities of genset starting from 5 kVi till 125 kVi. Any questions on this, sir?
No, sir.
Okay. Am I good? Hello.
Hello.
Anyone have any questions on this, sir?
I think the participant, my network connection is low.
Sorry, sir.
There are no questions, sir, as of now.
Okay, this is the basic process of the biogas plant and the anaerobic digesters. Okay.
And one person, Mr. Syed, he's asking your contact number to be shared in the chat box.
Sure.
If you're willing, you can share it.
Sir, anyone wants to set up institution level biogas plant or household purpose biogas plant, or if they're looking for any waste management solutions, right? Okay, they can find our number in the last of the PPT, which is shared, and also I'm putting that in the chat box. You can contact us on this number. Okay, we'll be there for you to help you with the solutions, or if you need any assistance on waste management, or if you want to buy a plant.
Okay, sir. On behalf of Department of Mechanical Engineering. One second.
One second, sir. I'll just share the picture of PPT there where they can find our numbers.
I guess the last slide.
Yeah. Able to access it. They can reach us on these numbers. All right. They can call us. They can Get Green Bioenergy is a company name. All right. We are located in HBR layout near BDA complex, Bangalore. Now that the NAC has made this biogas plant mandatory in the campuses, we're looking forward for the institutions to take the initiative of installing this in their campus and maintaining the waste in a way that which is eco-friendly. At the same time, they're producing the energy out of it. This actually helps us to get a A-grade certificate from the NAC.
Okay. Thank you, sir. Thank you for your wonderful talk on anaerobic digestion, as well as you showed many of the videos which you're working on and you already worked. We thank you on behalf of Department of Mechanical Engineering for sharing your technicality with respect to waste management. Thank you once again, sir.
Thank you so much.
We hope to meet you in future events also. Thank you.
Sure. Thank you for the opportunities.
Thank you, sir.